A particle moves along a straight line. Its displacement s meters from a fixed point O after time t seconds is given by s of t is equal to 4.3 sine of the square root of 3t plus 5, where t is between 0 and 10. The particle comes to rest after q seconds. Find q. Okay, so let's talk about how we would find q in this case. What we would need to do is we need to figure out when the rate of change is 0, right? The particle comes to a rest after q seconds. In order to find q, we need to figure out when the velocity is 0. In order to do that, we need to find the derivative and set the derivative to 0 because the derivative represents the rate of change or the velocity. And then we need to solve for t at that point. What is the time in this case? And so, in other words, we're going to treat q and t interchangeably in this situation because q is a specific time when s of t is equal to 0. Or, sorry, s prime of t is equal to 0. So first we need to find out what s prime of t is equal to. Well, we need to use our chain rule for this. It's going to be 4.3 cosine of the square root of 3t plus 5, and then times the square root of 3t plus 5 derivative. Okay, so what's the derivative of that then? Well, that derivative is going to be, let's see, I'm just going to rewrite everything else first. That derivative is going to be 1/2 times 3t plus 5 to the negative 1/2. And that is equal to 4.3 over 2, which is 2.15 cosine of root 3t plus 5 all over 3t plus 5 rooted like that. And also we should set this equal to 0. And then at some point we should swap t for q. So then we're going to end up with cosine of the square root of 3t plus 5 is equal to 0. And when is cosine 0? Well, it's 0 at pi over 2. So therefore, we would need the square root of 3t plus 5 to be equal to pi over 2. And then if we solve that, we should get that t or q is about 5.74 seconds approximately in order to make that happen. All right, so that's it for that one.